All right, to start today's lesson, I just want to do a quick recap of what we learned last time. We had our introduction to rational functions, and it was notes number 21. And we started by looking at a graph and learning what limit notation was. So as x approaches a particular number, the y values are approaching something, and we put that together and called it a limit. So we practiced that a little bit. And then we started learning about graphing rational functions. We started with plotting some points to get an idea of what the general shape is, and we looked at where they might have asymptotes. And then for problem number 2, we associated limits with asymptotes. So for every asymptote, we have 2 limits. And the way we graphed number 2 was to take our graph of number 1 and shift it to the right one because of transformations. So we're going to pick up here with number 3, and this will be notes number 22. Rational functions continued. So now we're going to graph y equals 1 over x plus 2. We can do just what we did last time, which was to think about what y equals 1 over x looks like. And that looks something like this. And then we can use transformations. So in this case, because it's x plus 2, we would shift it 2 to the left. So I'm going to go ahead and shift the asymptotes. There would have been a vertical asymptote at x equals 0, so now it's at x equals negative 2, 2 to the left. And the horizontal asymptote is still at y equals 0. And then if you want to get a couple of points to plot, you could plug in some numbers like if x is negative 1, then we have 1 over negative 1 plus 2. So we have 1 over 1. So we could plot the point negative 1, 1. On the other side, if we have x equals negative 3, then we have 1 over negative 1. So we can go ahead and sketch the curves. Okay, now let's list the asymptotes. So our vertical asymptote is the line x equals negative 2. And our horizontal asymptote is the line y equals 0. So for the vertical asymptote, the limits that we want are, we want to describe what's happening to the left of negative 2 and to the right of negative 2. So the limit of y as x approaches negative 2 from the left would be notated like that. And the limit of y as x approaches negative 2 from the right would be notated like this. A little plus after it means from the right. Okay, so what is happening to the graph? As x approaches negative 2 from the left, the graph is going down toward negative infinity. And as x approaches negative 2 from the right, the graph is going up toward positive infinity. And then the limits that we have associated with our horizontal asymptote are always the limit of y as x approaches infinity and the limit of y as x approaches negative infinity. And that means what's the end behavior? As we go further to the right and further to the left, what are the ends of the graph doing? It doesn't matter what the graph is doing in the middle. What is it doing as you go toward the ends, sideways? So we can see that it's approaching a height of 0 on both sides. So those limits are both 0. And as I said last time, whatever you have for your horizontal asymptote should be the same as the values of those 2 limits. So those limits should be really easy to do. Okay, now here's the thing. Not every function is going to be a transformation of y equals 1 over x. They're going to get more complicated, so we're not going to be able to rely on transformations anymore. So we need to look at some other things that we're noticing. So one of the things we should be noticing is that if the denominator is x plus 2, and therefore the domain is all real numbers except negative 2. Remember, you can't have negative 2 on the bottom. That exception to the domain is where we have the vertical asymptote. X equals -2 is the number that made the denominator 0. And if you look back at number 2, the vertical asymptote was at x equals 1, and x equals 1 is the number that makes the denominator 0. So if all we have is the equation, and we want to know where its vertical asymptote is, we ask ourselves, what number makes the denominator 0? Now, we're going to learn next time an exception to this, but for today, that's as complex or complicated as it's going to get. So let's take a look at number 4. If you want to know where the vertical asymptotes are, you ask yourself, what numbers make the denominator 0? And there are actually 2 of them. Because there's an x minus 1 on the bottom, x equals 1 makes the denominator 0. So x equals 1 is a vertical asymptote. Because we have x plus 2 on the bottom, x equals -2 also makes the denominator 0. So x equals -2 is also a vertical asymptote. So if I was to graph those, we would have a vertical line x equals 1 and a vertical line x equals -2. The vertical asymptotes divide the graph into parts. So this graph is going to have 3 parts. It's going to have a part over here, it's going to have a part over here, and it's going to have a part over here. 3 curves. Okay, how about our horizontal asymptote? So what we need to do is remember that the horizontal asymptote relates to what's happening to y as x approaches infinity and as x approaches -infinity. So as x approaches infinity, let's imagine x to be a really large number. Like what if x was 1 million or 10,000 or something really big? What if we were to substitute 1 million in for x? Then our fraction would be 1 divided by almost 1 million times a little more than 1 million. It's pretty close to 1 divided by 1 million squared. That is a very, very large denominator. And what's going to happen if you divide 1 by a very large number? You're going to get a very, very small number. And what do we mean by a very, very small number? We mean basically 0. So 1 divided by a million squared is very, very close to 0. And remember, the limit is saying what you're getting really close to. It's not saying what you actually reach. You may or may not reach 0, but that doesn't matter for a limit. It's what you're getting close to. So the horizontal asymptote is the line y equals 0. So notice on this one, we didn't start by graphing. We're actually going to end with graphing, and we're starting with figuring out the features so that we can graph them. So let me go ahead and put that horizontal asymptote in place. Okay, now let's figure out the limits that are associated with the vertical asymptotes. The limit of y as x approaches 1 from the left, and the limit of y as x approaches 1 from the right. Now once again, I'm not going to be able to do this by looking at my graph because I don't have a graph yet. So what I'm going to do instead is imagine a number that is a little bit less than 1 and a number that's a little bit more than 1. So let's say I'm using the number 1, let me do the less than 1 first. 0.99. That's a little bit less than 1. So if I have 1 divided by 0.99 minus 1, times 0.99 plus 2, I have 1 divided by something that's very, very close to 0 times 3. Something very close to 0 times 3 is still very close to 0. And if you take 1 and you divide it by something that's very, very close to 0, it would actually be a tiny bit less than 0 because 0.99 minus 1 is negative. If you take 1 and you divide it by a tiny, tiny negative number, you're going to get a very, very big negative number. So it's going to -infinity. Now let's do the same thing with a number slightly more than 1. So let's take 1.01 as an example. If I have 1 divided by 1.01 minus 1, times 1.01 plus 2. It's 1 divided by something that's very, very, very close to 0, but positive, times 3. And 0, something very, very small, like 0 times 3 is still going to be very, very close to 0. So here we're taking 1 and we're dividing it by a tiny, tiny positive, and that's going to give us positive infinity. So here's what we know from that. We know that to the left of 1, our graph is going down to negative infinity, and to the right of 1, our graph is going up to positive infinity. Now let's look and see what's happening to the left and the right of negative 2. I'm taking my time with this one because this is the part of the problem that confuses students the most, and this is our first time thinking it through this way. What's the limit of y as x approaches negative 2 from the left? And what's the limit of y as x approaches negative 2 from the right? So I want you to think of a number that's a little bit to the left of negative 2. That would be something like negative 2.01. To the left of it means smaller, so not negative 1.99, but negative 2.01. So what happens if I plug that in? So I have 1 divided by negative 2.01 minus 1. Well, that part's basically negative 3. Negative 2.01 plus 2. Okay, that part is very, very, very tiny negative number. So I have 1 divided by a positive number divided by a very, very tiny negative number. And that's going to give us 1 divided by a tiny negative. So that's going to be a really, really huge number, negative infinity. And then what happens if I use a number that's slightly to the right of 2? Like slightly to the right of negative 2, like 1.99, negative 1.99. Then I have 1 divided by negative 1.99 minus 1, that's basically negative 3. And then multiplied by negative 1.99 plus 2, that's basically a tiny, tiny positive. So 1 divided by negative 3 times something slightly more than 0 but positive is going to be negative infinity again. So I feel like I probably need to go back to my other one because I think I made a mistake. So let's go back and try negative 2.01 again. I think I dropped a negative sign somewhere. Sorry about that. So negative 2.01. So we have 1 divided by, I think this might be where I made my mistake. Negative 2.01 minus 1 would be negative, and then negative 2.01 plus 2 would be negative. So we actually have a negative times a negative on the bottom. So 1 divided by a tiny positive denominator is positive. So we're going to put positive infinity. So that means to the left and the right of that particular asymptote, to the left of negative 2, it's going up to positive infinity, and to the right of negative 2, it's going down to negative infinity. So, based on that, and based on the idea that we know as it heads out toward the sides, the end behavior is it's going towards 0, I'm thinking that the graph is something kind of like this. We still don't seem to have a whole lot of information. So what would be nice is if we could gather a little bit more information, like on the intercepts, x-intercepts, y-intercepts, and perhaps some extra points. So that's where we're going to head with the next one. Okay, what we're going to do is find the y-intercept, the x-intercepts, as well as the asymptotes, the limits, and draw the graph. So to find a y-intercept, no matter what, you always plug in 0 for x. No matter what kind of function you have. So if I plug in 0 for x, I get y equals 0 plus 1 over 0 minus 1, and that's negative 1. So the point is 0, negative 1. To find to find an x-intercept, you always plug in 0 for y. So that would give us 0 equals x plus 1 over x minus 1. So if you have 0 equals a fraction, the only way that's possible is if 0 equals the numerator. Remember, you can't have 0 in the denominator, so it's just 0 equals the numerator. So you don't even need to worry about the denominator. 0 equals x plus 1, and that's going to give us x equals -1. So the x-intercept is the point -1, 0. Okay, now for asymptotes. Remember last time we noted that whatever number makes the denominator 0 is going to give us our vertical asymptote. So vertical asymptote, x equals 1. And so that means we're going to have a couple of limits, the limit of y as x approaches 1 from the left, and the limit of y as x approaches 1 from the right. Also, to find the horizontal asymptote, we want to imagine that x is getting really, really large, like 1 million, 1 billion, etc. What happens if you have 1 million plus 1 over 1 million minus 1? That's awfully close to just a million divided by a million, and that is basically 1. So it's very close to 1. So the horizontal asymptote is y equals 1. Okay, and that means that we're going to have these limits. The limit of y as x approaches infinity is 1, because it's going to match the horizontal asymptote, and the limit of y as x approaches negative infinity is 1. Okay, those limits describe the same thing that the horizontal asymptote describes. As we go further out sideways, it's getting closer to a height of 1. So we just need to evaluate the other two limits that I started, and then we can draw the graph. Okay, so when x is a little bit less than 1, let's imagine that as 0.9. So if we have 0.9 plus 1 over 0.9 minus 1, you have something close to 2 over something really, really small but negative. So you have a positive over a negative. This is how I want you to show your work. You have a positive over a really tiny negative, very close to 0. So that's going to be basically going toward negative infinity. What if x was something a little bit more than 1, like 1.1 or 1.01? 1.01 plus 1 over 1.01 minus 1. That's pretty close to 2 on the top. That's positive, and that's really close to 0 on the bottom, but positive. So we have positive over positive, and that's heading toward positive infinity. Okay, let's put all this together and draw the graph. So first I'm going to draw my asymptotes, x equals 1, y equals 1. And then I'm going to plot my points, 0, -1, -1, 0. And then according to the asymptotes, it should be going, I'm going to put my pencil on one of those points, go through the other point, and it should be going up toward a height of 1 for the end behavior. And then according to my limits, as x approaches 1 from the left, it should be going down to negative infinity. Now there's going to be a curve on the other side, and you can probably guess it's going to do something like this. But what I'd like to do is find a point to anchor it down. So I'm going to go ahead and find an extra point. And to find the extra point, you just simply choose a number, like x equals 2, plug it into the function. 2 plus 1 over 2 minus 1 is 3 over 1, so that's 3. So let's plot the extra point 2, 3. And then according to our limits, to the right of 1 it should be going up to infinity, and then as we go further out it should be going down toward height of 1. Okay, so that is our big problem for rational functions. Find the intercepts, find the asymptotes, find the limits, draw the graph with extra points. You always need at least one point for each region. So if you have a region to the left of the vertical asymptote, you need at least 1 point over there. And if you have a region to the right of the vertical asymptote, you need at least 1 point over there. More points are fine, especially if you don't think your limits are right or you don't know what to do. You can plot more points, and that will help you see what the curve is doing. Oh boy, there's another one. Wow, this is going to be a long video. Okay, so let's go ahead and power through it. So to get the y-intercept, plug in 0 for x. So we have 0 plus 1, over 0 minus 1 times 0 plus 2, and that's going to give us negative 1/2. So we have the point 0, negative 1/2. To find any x-intercepts, plug in 0 for y, and that means essentially just set the top equal to 0 because the bottom can't be 0. Solve for x and we get negative 1, so we have the point negative 1, 0. For the asymptotes, vertical asymptotes, look at what makes the denominator 0. That would be x equals 1, and also x equals negative 2. So we'll have two limits for each of those. We're going to have the limit of y as x approaches 1 from the left, and the limit of y as x approaches 1 from the right. And we're going to have the limit of y as x approaches negative 2 from the left, and the limit of y as x approaches negative 2 from the right. And for the horizontal asymptote, if you plug in 1 million to the top for x and 1 million to the bottom, each time you have an x, you get 1 million over 1 million squared. So the bottom is so big compared to the top that it's heading towards 0. Y equals 0. I would call it bottom heavy because the bottom is so much bigger than the top. So that means we're going to have the limits. Limit of y as x approaches infinity is 0, and the limit of y as x approaches negative infinity is 0. Okay, so we need to finish our other two limits. So to the left of 1, take a number like 0.9, and when you plug it in, the numerator is positive, 0.9 minus 1 is negative, and 0.9 plus 2 is positive. Positive over negative times positive is negative, so that one's going to be negative infinity. For something to the right of 1, let's use 1.1. So for the numerator, 1.1 plus 1 is positive. For the denominator, 1.1 minus 1 is positive, and 1.1 plus 2 is positive. Positive over positive times positive is positive infinity. For something to the left of negative 2, let's use negative 2.01. So the numerator is going to be negative, and the denominator is going to be negative times negative. Negative divided by negative times negative is negative, so negative infinity. And for something to the right of negative 2, maybe negative 1.09, the numerator is negative, and the denominator is negative times positive, so that's going to work out to be positive infinity. Okay, so let's draw the asymptotes. X equals 1, x equals negative 2, y equals 0, and let's plot the points. 0, negative 1/2, negative 1, 0. Notice that that point lies on the horizontal asymptote. So if you were thinking that you couldn't ever cross an asymptote, that's actually wrong. You can cross an asymptote. Points of the curve can be on the asymptote. The asymptote just tells you what's happening as you go further out. Okay, so now according to our limits, to the left of 1, we're going down. To the right of 2, we're going up. So that section in the middle looks like that. Now I need an extra point for the left section and an extra point for the right section. So let's do negative 3. And when we plug it in, negative 3 over negative 4 times negative 1, that works out to be negative 3/4. So we can plot that. And then according to our limits, we should be going down to the left of negative 2. So it's going to do this. And then for another extra point, let's use x equals 2. And that gives us 3 over 1 times 4. So that's 3/4. So we can plot that point. And then according to our limits, to the right of 1, we should be going up to infinity. So it looks like that. Okay, fantastic. So you only have 2 homework problems, and I want you to use the full big problem process. Find the y-intercept, the x-intercepts, the asymptotes, the limits, and draw the graph with extra points where needed. Thanks, everybody.